in this lecture series we will be studying MOSFET. But the thing is that before studying MOSFET, we will first try to understand that why do we need to study MOSFET. Like what are the things that can't be done by the diode. Like diode, as you all know that diode is a two-terminal device. I think you all must have studied about diode. It is a two-terminal device, and before MOSFET in analog electronics, we all study about diode. So what are the things that can't be done by diode, for which now we need to study about MOSFET. So let's see. If we do small signal analysis for diode, whenever diode is on, we replace the diode with, in small signal analysis, we replace the diode with RD, which is equal to N upon IB. And whenever diode is off, we replace the diode with RD equals to infinity. That is, we replace it with open circuit. So now, if we so now if we see the circuit like this, this is R, this is VDC, and this is VAC. So if we do the small signal analysis for this, then here and see, this is plus, this is minus, so it is V0. This is our output voltage V0. Now if we consider diode to be on, diode is on, if we consider, then what will be our V0? V0 will be equal to VDC plus RD upon RB plus R into VAC. So here if we see here, this term RD upon RD plus R, this will be less than 1. Why? Because if we consider, let's say if RD equals to 2, randomly just consider RD equals to 2 or RD equals to any number, then and R equals to, R also will be some value, so let's consider it 1, then RD upon RD plus R will be 2 upon 2 plus 1, that equals to 2 upon 3, and this is less than 1. So this value is less than 1. Any value if you take, it will be less than 1 only. So here V0 equals to VDC plus RD upon RD plus R into VAC, and since this is less than 1, so this term will be less than VAC. So our output voltage is not even equal to our input voltage. Like our input voltage is VDC plus VAC, but here we are getting smaller value. And if we consider diode off, that is that if diode is off, then V0 equals to, we will replace this with open circuit. So V0 equals to VDC plus VAC. So if diode is off, we can see that our output voltage is equal to our input voltage. So we don't get amplified output here. means not getting, we amplified, output voltage. So now we can say that if it is our diode circuit, and this is our input voltage, and let's say Vi equals to Vm sin omega t, and this is our output voltage, that is V naught, and let's say V naught equals to K into Vm into sin omega t. Then we can say that here it is not possible that K value mod of K, that is positive value of K, is greater than 1. This is not possible. So we just cut it. It is not possible, as we saw in the earlier slide. So that's why we need 3 or 4 terminal devices for amplification of the input. Now, if let's see, let's say it is 4 terminal devices, so this is our first terminal, terminal 1, terminal 2, terminal 3, and terminal 4. And in these 4 terminals, one of our terminal will be controlling terminal. Controlling terminal means it will control variables like current. So this is our 4 terminal devices. It is what it looks like. So in another video we will study what is a basic amplifier and what are the types of